This is a pretty complicated looking integral, but we are given the substitution to use. We can replace this dx by dx by du du. Dx by du is then going to equal minus u to the minus 2. And u to the minus 1 is going to be x minus 1. Stick with that for the moment. So I is going to be the integral of 1 over. Now, it's up to you. You can either change the dx by du in terms of x, or you can change the x's in terms of u. They kind of said, they're kind of implying to change the x's to u like they've done here. So I'll go with that. I'm going to get u to the minus 1 on the bottom, and then square root of x squared minus 1. I'll deal with that in a minute. And then I'm going to be timesing by minus u to the minus 2 du. I can actually imagine that this is up here in the fraction, and I can times top and bottom by u, and essentially this cancels out with this, and I'm left with a minus 1 there. I'm going to bring the minus out of the integral, and then I'm going to write this as u to the minus 1 on the top, all divided by, now it's a case of sorting out x squared minus 1. Well, this is the difference of two squares, so it's x minus 1, x plus 1. Which is the square root of x minus 1 multiplied by the square root of x plus 1. So this x minus 1 is actually the same as u to the minus 1, so it's going to be actually u to the minus a half here. And then the x plus 1 is a little bit trickier, but if I add 2 to both sides, I'm going to get u to the minus 1 plus 2. These are actually going to partially cancel, so I'll be left with u to the minus a half over u to the minus 1 plus 2 to the half. Which I could write as u to the minus 1 divided by u to the minus 1 plus 2, all raised to the power of a half. Okay, we're getting there with this manipulation. Now I don't really want, reciprocals in my fractions. And to be fair, could I have got rid of it earlier? Well, it was tough because of the type of substitution we used. And you might have got to something like this using, just a slightly different route. I can times top and bottom by u. So I'm actually going to get 1 over u. Sorry, 1 over 1 plus 2u to the half. And suddenly this is looking a lot better because I can write that as 1 plus 2u to the minus a half. And we've gone from something that was really complicated, I think anyway. Oh, here we are. Through this substitution, we've turned it into a fairly standard integral. So what do we do here? Well, I'm going to add 1 to the power, divide by this new power, which is the same as timesing by 2. Just I have to also divide by 2 because of the 2u. So they're actually going to cancel. You can check, of course, if you differentiate this, I'd bring the half down, I would times by the 2 using the chain rule, so they would cancel, and I would lower the power. it works. I just need to remember that I've got a plus c in there. Now the final answer they've asked for in terms of x. So let's not forget, we've got our answer in terms of u, and u is going to be 1 over x minus 1. So 2 times 1 over x minus 1 is going to be 2 over x minus 1. Let's put it over a common denominator. And finally, we're there. It's going to be x plus 1 over x minus 1 to the half plus c. You may have found it a bit easier to change this u to the minus 1. Let me just write in a different color. It would have been x minus 1. Like, arguably, that might have been simpler to cancel things down earlier on. Ultimately, you would have, well, you would have maybe then got, you would have to realize to cancel the x minus 1 and divided by root x minus 1, you would have got this on top. We still would have then had done the substitution back in terms of u, which would have led us over here and then bringing it back to this. But yeah, that would have worked as well. In part B, it is the same integral again, but just this time with limits. Limits sec alpha and sec beta. So we can go straight to writing. Okay, let's just write the integral down. This is going to equal, we can just basically substitute the limits in. Let me, yeah, okay, I'll write down the results. I'm going to get minus, I'll put the square root in now, I think. Okay, forget the constant. And then minus minus, so it become a plus. Now, somehow combining this, sort of turning this into cots does not seem at all easy. My first thought would be to get it in terms of cos times top and bottom through by cos beta. So we've got 1 plus cos beta, and then 1 minus cos beta. And the same over here, but times top and bottom by cos alpha. Now we can think how to somehow, improve these. Like there's no square root in the answer, so we're going to have to somehow get things in terms of squares. And we've also got half angles going on. So the thing that I would think of is let's look at some double angle formulae, and then we can turn them into half angle formulae. So cos 2a is identical to cos squared a minus sine squared a. Now there's no sines in sight, so I can replace that by 1 minus cos squared. I'm going to get 2 cos squared a minus 1. This is looking good because then cos 2a plus 1 is equal to 2 cos squared a. And that means that cos um, beta plus 1, or sorry, alpha plus 1, for example, is going to be 2 cos squared alpha over 2. But essentially, let's a equal alpha over 2. And we'll get the same for beta. Okay, that's pretty good. The other one looks trickier, but actually there's one formula that I didn't write down. Because if we replace cos squared, and remember in the final answer we've got cot, so we're going to need sine at some point. This is also equal to 1 minus 2 sine squared a. And that kind of, sorts it out a little bit, because that means that 1 minus cos 2a is going to be 2 sine squared a. And I'm in a similar position to up here now. So this means that 1 minus cos alpha is going to be 2 sine squared alpha over 2. And the same for beta. Therefore, the integral is going to be minus. Actually, I could write the alphas first. So I've got 1 plus cos alpha, which, as we said, is up here. So it's going to be 2 cos squared alpha over 2. Then I'm dividing by 1 minus. Was it alpha? Yeah, 1 minus cos alpha. So 2 sine squared alpha over 2, all square rooted. These cancel. And I'm just going to be minusing the same again, but in terms of beta. This is none other than the square roots of, it's cos squared over sine squared, so it's cot squared. The squares and the square roots cancel. And we're left with this much nicer answer as was asked for. Okay, that's good. And these are the limits. Well done if you got there. The clue, remember, in these sorts of questions is seeing that in the answer there's half angles. So you got to think, okay, double angle formula going to come in somewhere. So this is your starting point. I should have written the other one down like straight away after, and then you can spot that, if you construct your half angle formula, then it's all going to work out.